I think we can start now. Hello everyone, welcome to today's session on statistics for data science, ML, and data science, ML, and machine learning. Wait, let me share my screen. Guys, you can see my screen, right?
Yes.
Alright. So welcome everyone. Today we're going to learn about statistics, which are important for ML, AI, and data science. Let me introduce myself first. I'm Francesca Rosa. I'm currently at Prague University. In my third year. Uh, okay, so these are the topics we're going to cover today. We're going to start from basic, from very beginning. Uh, these are these are the topics we're going to cover today's agenda. Uh, we're going to first understand what is statistics. Then we're going to deep dive into the two type of statistics. Then we are going to distinguish between sample data and population data. Then we are going to also learn about some sampling techniques. And then we are going to learn about data, or you can also say variable, and different types of data or variables, and measure of level of measurement or scale of measurement. So I think we can start from now. All right. So, uh, what is statistics? What is statistics, guys? Statistics is the science of collecting, organizing, and analyzing data. We can say in the field of mathematics that statistics is a branch where we collect, organize, and analyze data to draw a verdict out of the sample data for the population data. Okay, so in statistics we organize, analyze, and what uh, we collect and we draw a verdict, or you can say conclusion out of data. So there are different kind of there are two types of statistics. There are two types of statistics. What are those? One is descriptive statistics, and another is inferential statistics. All right. In the domain of descriptive statistics, we mainly organize and summarize data. What we do in the descriptive statistics, we mainly organize and summarize data. Maybe you have heard of mean, median, mode, standard deviation, variance. All these topics falls under descriptive statistics. Then we have inferential statistics. Okay, let me describe this descriptive statistics a bit. in this thing, we are going to know about measure of central tendency, where we have mean, median, mode. Then we have measure of dispersion, where we have variance, standard deviation. Then we also have measure of position, skewness. We will cover all these topics one by one. I will continue this community session for maybe 7 to 8 days. I will cover all the topics that is needed for data science and statistics. So, okay, this is that. And in the inferential statistics. So, guys, do you know what does inference means? What does inference mean? Inference means a conclusion reached on the basis of evidence and reason. Okay, that is inferential statistics. So, mainly in the inferential statistics, we're going to draw a verdict out of the data, right? We're going to draw a verdict or conclusion in the inferential statistics. Here we have all sort of tests, Z test, T test, ANOVA test, all sort of tests are will be covered in this inferential statistics. Z test, T test, ANOVA test, then hypothesis testing, then then we have confidence interval in this topic also. Confidence interval, different kind of distributions. All will be covered in inferential statistics. So these are two main classification of statistics. Today we are going to learn about descriptive statistics. Uh, guys, please let me know if my handwriting is understandable. Do you guys understand my handwriting? Is it okay? I'm getting used to this, graphics tablet and also, yeah. Alright. So let's move forward. Now we're going to talk about sample. Now we're going to talk about we have covered introduction and two kind of statistics. Now we're going to talk about sample data and population data. Okay. Sample data and population data. So firstly, let's start with population data. You know what is population data? Population data is a collection of all items of interest. Population data is collection of all items of interest, and it is denoted by uppercase N. Then we have sample data, which which is a subset of population data. Okay. Let me give you some examples, and you will understand. Suppose you walk into a campus of XYZ University. Just a second. Suppose you walk into a campus of XYZ University and you find every student. Will it be the population of XYZ University? I mean, when you walk into a random university, suppose XYZ University, then you find every student of that university. Will the students staying at the university be the population? The answer is no. The population of interest includes not only the students on the campus, but also the students who are attending classes from online, or also you can say from the students who are there on exchange program. We have exchange programs, right, where students from different university goes to abroad or any other university to represent their culture and all. So the students that are not present in the campus, but they will also be a part of the population. So what is the sample of that XYZ university? Um, so if you think the let's say the students staying at the cafe will be the sample of that university. Why? Because in the cafe most people are there. Mostly the cafes are crowded. So we can say the population of XYZ university in this region, the students who are attending from online, the students who are there for exchange programs, the students who are currently studying there, all will be the part of population. But if we talk about sample, if we go to the cafe and let's say we interviewed 50 or 70 students, those students will be the sample data. So sample is a part of population data. Okay, and then let's say you have 10 classroom, then you go to the 10 classroom, and no, the 10 classroom is your population data, and from that 10 classroom, this 10 classroom is your population data, and from that 10 classroom you go to 2 classroom to collect data. So these 2 classrooms are your sample data, or you can say you're doing a survey on Dhaka city, and people staying in Dhanmontri or Uttora are the sample data. But you have to keep two things in mind, that sample data should be representative and it should be random. Okay, let me ask you a question. Suppose you're trying to you're trying to estimate the average valuation of startup in USA. You're able to visit 200 startups in Silicon Valley in a random manner. Okay, so guys, my question to you is, do you find any problem in this study? Okay, so let me tell you, the problem in this study is that the sample data that we have collected are only from Silicon Valley, right? But we are supposed to calculate the whole startups which are in USA. I mean, all the states. We have to think about all the states situated in USA. Silicon Valley does not represent the 49 other states, right? So the problem in this problem statement is the sample data. Sample data was not represented. It did not represent the whole US. Okay, so we have covered sample and population. Guys, do you have any problem in sample data and population data? Please let me know if you have any problem with this topic. Okay, so I think we can move forward. Now, you've seen that we have collected the samples quite randomly, right? But there are some sampling techniques. There are some sampling techniques that you need to know. Let me talk about those sampling techniques. Now we are going to talk about some sampling techniques. Now we're going to talk about some sampling techniques. Okay. The first sampling techniques is simple random sampling technique. Simple random sampling. I think by name you can understand what does the sampling technique means. You randomly collect data. Randomly collect data from the population, which means if this is the population and these are the data in the population, every single data will have the chances of chances of will every data will get the equal chances of being selected. Okay, so suppose there are 500, the population data is 500. So this 500 people or this 500 objects will be getting the equal chances of getting selected because this is random. You're not doing this sampling technique in a specific for a group of people. You will understand what I'm talking about in stratified sampling. You will understand what I'm saying. The group of people, what I'm meaning by that. Okay, the stratified sampling. Okay, in this stratified sampling, the main thing that you have to keep in mind that the data the data should be non-overlapping. The data should be split into non-overlapping groups. Okay, so the data should be split into non-overlapping groups. Suppose, what do I mean by that non-overlapping groups? Suppose genders can be an example, male, female. Suppose we're doing a survey where we want only females to participate, or we want only the male to participate. So that survey will be done only on female or only on male. So that is stratified sampling. Or we can also say, suppose ages, from we're gonna do a sampling where people based on different ages, let's say 0 to 10, 10 years, 10 to 11 to 20 years, or 20 to 30, only people from this specific age group can participate in this sampling techniques. Suppose we can also do this survey based on profession. Only doctors or engineers can apply. You know, this type of things will be under stratified sampling. Okay. Then we have another type of sampling, which is systematic sampling. In systematic sampling, we're going to do the survey on the nth individual. Suppose this is your population. These are the population data, and we're going to choose only these people, only nth number. Suppose mm, you walk into a cinema hall. The people who have watched the cinema are going to review about the cinema. Now you only choose the you only choose every fifth person coming out of hall. Okay, you're going to choose every fifth person coming out of hall, and you will gonna ask them that how was the cinema and all the things that you are going to, ask them for your survey. So that is systematic sampling. Sorry, uh, nth individual is the main individual. Every nth individual is the main interest of our this type of sampling. Or you can go to a mall and ask every ninth person about the survey you are working on. Then you have convenience sampling. In this sampling, in this sampling technique, only domain experts will walk in. Only domain experts. Okay. Okay. Then let me give you an example. Suppose we are doing a survey on some dental procedure, right? We're doing a survey on some dental procedure. Only the dentist can enter this survey. Only the dentist can participate in the survey. Right. Uh, so, okay, let me ask you a question. Suppose uh, we're doing a survey on some makeup products. We're doing a survey about the makeup quality and so on. So, what kind of sample do we need, and what kind of sampling technique we will use in this survey, in this type of survey? What do you think? We're doing a survey on quality of makeup products, and what kind of sampling we will use to do this survey? What do you guys think? Okay, we can say convenience, but the convenience sampling is more about people who are professional. I mean, this is strictly what does it say? How do I put it? This type of sampling is strictly defined for the people who are professional in that domain. Okay, no, the answer will be stratified sampling, because see, we're thinking about two genders here, male and female. Mostly female, I mean females use makeup products, right? But yeah, we have male artists or male. Just a second, please. Yes. We also have male actors who use makeup products, but the large population is female, right? So we will be more concerned about doing this uh, doing this survey on female. So that would be stratified sampling. And sometimes, on different cases, the thing can both be stratified and convenience sampling. It can be both on based on the scenarios. Guys, I'm so sorry for my handwriting. I'm just getting used to it. Please bear with me, guys. Okay. Um, Suppose we are going to do a survey on drugs. By drugs, I mean medicine. Okay. We're going to do a survey on some drugs. So, what do you think? What kind of sampling technique would be the best for to do this type of survey? What do you think, guys? What would be the best sampling technique for this type of survey? We're going to do a survey on drugs. Okay, let me tell you. I okay. So convenience sampling. convenient sampling would be the best. You know, the people who are in charge to make the drugs, who are professional, will take care of this. Will be the best people to answer this kind of survey. Okay, guys, do you have any question from this part, or I can move forward? We are done with different types of sampling techniques. Then we are going to talk about data or variable and different types of data and variable. Okay, let me move forward. What is variable? Can anyone say what is a variable? Okay. Uh, let me let me write it. Any characteristics, numbers, or quantity that can be measured. Any characteristics, numbers, or quantity that can be measured is known as variable in the field of data science or statistics. Can be measured. Okay. So we have two type of data. One is quantitative data and another is qualitative data. So what is quantitative data? Quantitative data are the data that can be measured numerically. Okay, quantitative data are the data that can be measured numerically. I mean, you can do addition, subtraction, multiplication with this type of data. I mean, numbers. So, quantitative data can be two types. One is discrete, and another one is continuous. Okay, and then we have qualitative data. Before going into qualitative data, with firstly, let me complete quantitative data. These are very easy topics, guys. We're just covering the basics of statistics today. In the further session, we will cover more advanced topics, right? So here we go. Quantitative data. Okay, quantitative data, discrete and continuous. Guys, can you give me a discrete example of quantitative data that are discrete? Yes, yes, yes. Height, weight, age. These terms fall in the quantitative data because these are numbers that can be added or subtracted or we can multiply. Yes, right, right, Tausik. Number of child in a family, absolutely right. These are yes, yes, yes. These are discrete. But the height, weight, age, this falls in quantitative data. But these data are not discrete. Okay, these are quantitative data, but these are not discrete. We will we will go into it. Okay, discrete data we have. So in discrete data, we are more concerned. We're concerned about the data that are whole number, such as number of child in a family, then then number of bank account. It's a whole number, right? Number of bank accounts. Then uh, then number of fruits, number of fruits in a basket. Guys, give me more example on the discrete data. Number of country, right, right. Okay. Now let's talk about continuous data. Okay. Height, weight, then then length of object. All these data are not whole number, right? We can't convert them into decimal points. So these data are continuous data. Now, okay, I'm gonna give you some examples, and you're gonna say what if that is discrete or continuous data. Okay. So first, let's see. Okay. Let me cover the qualitative data first. Before that, what is a qualitative data? Qualitative data are data based on categories. Okay. Qualitative data can be also written as categorical data. It's also known as categorical data. Right. So based on category, by category I mean gender, then blood group, then t-shirt size. These are all category, right? These are not numbers. You cannot multiply, subtract it. So these things will fall under qualitative data. Now I'm going to give you some examples and you're going to tell me whether it's a quantitative data or qualitative data. Marital, marital status, What do you think? What kind of data is this? Yes, qualitative data. Right, right. Qualitative or categorical. Okay. Then we have mm, blood pressure, quantitative. Excellent. Then blood group, quantitative. Then if we talk about blood group, what kind of data this is? Yes, qualitative data, right? Then uh, let's say gender. What kind of gender? Qualitative is not right. So now we have learned about discrete continuous data which falls under qualitative data, quantitative data, and then we have also covered qualitative data. Now let me move forward. Guys, do you have any problems till now? Please let me know if you have any problems or any topics that you have not understood. Thank you. So let me move forward. So now we are going to learn about levels of measurement or measurement scale. Variable measurement. Okay. So we have four type of variable measurement, four type of data. The first thing that we're going to talk about that is nominal nominal data. Then we have ordinal data. Then we have interval data. And then we have ratio data. Mm, all right. So these two type of data are qualitative data and the data that will fall under interval and ratio are quantitative or categorical data. So if we talk about nominal data, in this part, the data that cannot be ordered will fall under nominal data. Okay, the data that cannot be ordered. Guys, can you give me some minutes because I'm facing some problem with my tab? Please excuse me for a minute. In the nominal data, we will be talking about those data that cannot be ordered. Let's say, let's say, uh, gender. Can you order male or female? You can't, right? Then eye color. Can you order eye color? Can't. Then you have different kind of seasons. Summer, spring, winter, etc. Yes. So the key in nominal data is that the data cannot be ordered. Then we have ordinal data. In this section, we will be talking about those data that can be ordered. So here the data can be ordered. Suppose suppose you are in a restaurant, you ate, you had your lunch, you had some fine fried rice, chicken fry, and so on and so forth. Whatever is your favorite. Okay. Then the waiter came up with a review card. Then there's an option. Suppose there is a part like this. Suppose saying disgusting or say neutral or then you have tasty. We have delicious. Okay. These are just words, but you can order them in a way, right? You cannot put the disgusting in between neutral and tasty because in your mind you have a order. So it goes from negative to positive. right? Then, mm, 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 suppose you can also think about your grade sheet, where we have F, then starting from the top, A plus, A minus, then B plus, then B. These are just some alphabets, but this has some meaning, and this cannot be, the A plus cannot be here, right? It has a certain position. It is ordered in a way. So this type of data are known as ordinal data. Though these are words, but this has some order. Okay. Then we have, so then we have interval data. The key point from interval data that it doesn't has a true zero. There is no true zero. Let me explain you what is a true zero. Okay. So you all have learned about the temperature scale, right? 0 degree Fahrenheit, 0 degree Celsius, 0 degree Kelvin. The 0 degree Celsius and 0 degree Fahrenheit are not same. Though these are denoted by zeros, but these have different meaning. The 0 degree Celsius and 0 degree Fahrenheit are made by humans. These are not actually the true zero. It doesn't mean the 0 degree Celsius doesn't mean that uh, the 0 degree Fahrenheit, that doesn't mean that the weather is very cool, does it? It doesn't mean that. Then we have date and time. Can you say that today is we can say that this is 1st of January, this is 2nd January, this is 3rd January. Can we say this is 0th January? There is no such 0th January, right? There is no such 0th January. That's why this type of data falls under interval data, the data that don't have true zero. Okay, and then we have, okay, another thing that I have to mention, that interval data and ratio data falls under quantitative data.